Okay, for the next kind of practice problems or examples you have in your green notes, we had this problem here that asked you to prove the triangles isosceles. QSR was isosceles. So I kind of went through some things that you need to kind of be able to recognize. Parts of a circle, special segments. You need to be able to recognize when they're drawn and their relationship. So if you need some assistance with the notes and the justification that I gave you on this, please kind of get into tutorials. I wanted you to try one on your own, which was this example here. So if you needed help working this out, let's go through it together. So your hint was first to find P. So by using the tangent theorem. So the tangent theorem says if you have a tangent, and we have two here, we have the tangent CD and we have the tangent DB. So I know that those two are congruent because that's two congruent tangents. That's the theorem. But the theorem for a tangent states that if you have a tangent and at the point of tangent C, when it touches a radius, it is perpendicular. So basically, we have two radii creating right triangles right there. And then I can use now those 90 degrees and the 40, use the quadrilateral to find the measure of angle P. So basically use your 360. So if I add these up, subtract from 360, we now see that angle P right here would be 140. And so that's where you kind of want to start, because if I know my central angle, then I can get to RQ, okay? Because if BOC is a central angle, then this arc here is equal to that central angle, so that's 140. And now to get to Q, Q is right here, it's an inscribed angle because the vertex is on the circle, and now it would be half that arc, okay? So it's going to be half that arc. So Q would be basically half the 140, so we know that Q is 70. Okay, so those pretty much is your explanation for that one. If you need to check the next example, let's go ahead and just hit the arrow and get to it. Thanks.